Currently, pollutants and dirt deposited on surfaces have been compromising the appearance of the buildings and durable performance of solar panels, leading to $7.5 million cleaning cost on campus every year. Superhydrophilic coatings can facilitate fast spreading of water droplets into ultra-thin continuous water film to loosen dirts, which equips coating with self-cleaning and anti-frosting features. However, current superhydrophilic coatings in the market are non-durable, poor photocatalysis, and worse anti-reflection. In addition, the application of conventional self-cleaning coatings can bring a detectable change of the original design and appearance of the objects, which is not desirable in most of cases. To tackle these issues, HKUST at Colert has synthesized a physically robust nano-coating via in-house polymer graft modification and encapsulation technologies. In contrast to commercial coating, this technique supports a unique micro-nano hierarchical structure via surface-treated core shell porous nanoparticles while maintaining high transparency and promoting superior adhesion with substrates for high photocatalysis, outstanding anti-reflection, and weathering-resistant abilities. First, the unique solid core porous shell structure processes a low refractive index to capture as more light as possible, improving superior anti-reflection for enhanced solar power generation. Second, the doped core material shifts the photoresponse range from ultraviolet to visible light, realizing efficient photocatalysis for superior self-cleaning performance. Moreover, the in-house synthesized organic binder small molecules allow the coating to have strong adhesion, long-lasting wettability, and resistance against weathering. This technology demonstrates a promising scalable and low cost for fabricating multifunctional green nanocoating with outstanding durability. Its application on PV panels can enhance energy harvesting efficiency by 20% and save about 50% on cleaning labor costs. It can also maintain buildings' aesthetic and clean appearance automatically as well as windows anti-frosting cleanness with unaffected views. We have closely collaborated with other industrial partners. Our project team includes Master of Science, PhD students, research staff, and business team to develop and demonstrate this technology in various eye-catching places in society. In this living lab, this coating technology has been commercialized and used in pilot applications over thousands of square meters. We will continue to collect data and make lifetime analysis, promoting continuous product updates and iterations to enhance competitiveness, and also contribute to the early realization of carbon neutrality by our green nano coating.